Hello everyone. In this section, you are going to learn double angle and half angle identities. All of these identities are deduced from sum and difference identities that you learn in section 4. We are given sine 2 theta, and we want to write it in terms of theta. We are given 2 theta. If we want to write it in terms of theta, we are going to use the double angle identity. So the expansion here is 2 times sine theta times cosine theta. For the cosine 2 theta, the expansion is cosine squared theta minus sine squared theta. Let's suppose that you are not given cosine, you are only given sine squared. So you can write cosine squared in terms of sine squared, as you learn an identity in section 3. So cosine squared is 1 minus sine squared. So 1 minus sine squared minus sine squared, 1 minus 2 sine squared. What if you are not given sine, you are only given cosine? You will do the same here. In place of sine squared, you are going to write 1 minus cosine squared. 1 minus cosine squared. So it's going to be 2 cosine squared minus 1. So actually you have one identity here, but you can produce more. Tangent 2 theta, the expansion is 2 tangent theta over 1 minus tangent squared theta. So let's find tangent 2 theta and cosine 2 theta if cosine theta is given in that interval. The interval is given so that we can find the missing trigonometric functions. What is missing here? Sine 2 theta is, here is the formula. We need tangent here. We are given cosine, but we don't know what our tangent is. By using the interval, we are going to find our missing trigonometric functions. So here is the coordinate plane between 270 is here. 360 is here, which means our angle theta is in the 4th quadrant. In quadrant 4, we have angle theta. Here we form a right triangle as we did before. So cosine is given. Cosine means adjacent over hypotenuse. Your adjacent is 1. Hypotenuse is 3. You don't know what your opposite side is. Use Pythagorean theorem. So 1 squared plus 1 squared plus, you don't know the opposite, x squared equals 3 squared. So as you perform the operations, you're going to find x as square root of 8. So our opposite side is square root of 8. So now you can talk about other trigonometric functions here. So what is your sine? Sine theta is opposite over hypotenuse. Your opposite is square root of 8. Hypotenuse is 3. Wait, we didn't think about the sine here. Please be careful about the sign. We found it as square root of 8, but what about the sign? This is in the negative direction. The sign in the 4th quadrant is negative. So here we have not square root of 8. You have negative square root of 8. Here we have negative sign here. It's extremely important. What about tangent? Tangent theta, opposite over adjacent. Your opposite is negative square root of 8. Adjacent is 1, so negative square root of 8 over 1. So you found your missing trigonometric functions. Now let's apply the formula. So let's do tangent first. Let me write the expansion. 2 tangent theta over 1 minus tangent squared theta. So it's 2 times tangent theta. We found it as negative square root of 8. negative square root of 8 divided by 1 minus negative square root of 8 squared. So it's going to be 2 times square root of 8 is 2 root of 2. So 2 times 2, 4 square root of 2 divided by square root of 8 squared is 8. 1 minus 8 is negative 7. So negative negative will go. So you'll have 4 square root of 2 over 7. 4 square root of 2 over 7 is the answer of the first one. What about the second one? Now let's talk about cosine 2 theta, yes. What is cosine 2 theta? It is cosine squared. You already know sine and cosine. You can use the first one. Or second or third, it's up to you. You'll get the same result. So cosine squared minus sine squared. Your cosine is 1 over 3. So 1 over 3 squared minus your sine. Here you got it as negative square root of 8 over 3 squared. So 1 over 3 squared, 1 over 9. Square root of 8 squared, 8 over 9, which is negative 7 over 9. So here are answers. So if you know your missing trigonometric functions, by just substituting values into the identities, you can find your results easily. Let's continue with half angle identities. Here we have half angle. The previous one was double angle, now it's half angle. Sine of theta over 2 is given as either positive or negative, depending on the location of theta over 2. Square root of 1 minus cosine theta over 2. For cosine of theta over 2, it's either positive or negative. Square root of 1 plus cosine theta over 2. And tangent theta over 2 is either plus or minus square root of 1 minus cosine over 1 plus cosine. So use half angle identities to find the exact value of each trigonometric expression. Tangent 75. So I'm going to use that identity here. Here we have a half angle. 75 is a half angle. Tangent 75. It's an half angle. So what's the sign of 75? 75 is in the first quadrant. So it's positive. Square root of the identity here 1 minus cosine theta. 75 is half. Theta over 2 is 75. It's half. Theta is the whole angle. So the whole angle here is 150. Half angle is 75. Whole angle is 150. So 1 minus cosine 150 divided by 1 plus cosine 150. You are going to write the value of cosine 150. So it's equal to square root of 1 minus, the reference angle for 150 is 30. We are looking for cosine 30, which is square root 3 over 2, but it's in the second quadrant. Cosine in the second quadrant is negative over 1 plus negative square root 3 over 2. Let's simplify it. You are going to find 2 plus square root of 3 over 2 minus square root of 3 under the square root. It looks so complicated. If you don't do steps like that, if you use your calculator, you will find the result as approximately 3.7. The next one, cosine 5 pi over 8. You need to figure out what 5 pi over 8 in terms of degree. So 5 pi over 8 multiplied by 180 divided by pi, which gives you, do simplification, you're gonna get 212.5. It's 212.5 degree. So you have cosine 112.5. That's the half angle. 212.5 is the half angle. Let's look at the formula. 212. What's the sign of that? 212 is in the second quadrant. Second quadrant, cosine is negative. So here you'll have negative square root of, apply the formula, 1 plus cosine theta. This is theta over 2. Theta will be double of it, which is 225 over 2. So it's negative it's equal to negative square root of 1 plus 225. The reference angle is 45. Cosine 45 is square root. Sorry about the pen. Square root 2 over 2. But it's in the third quadrant. In the third quadrant, the sign of cosine is negative over 2. I'm not going to do the calculations. You can do it on your own. So it's going to give you the result as negative square root of 2 minus square root of 2 over 2. Approximately, it will give you the result as negative 0.38. These are the first type of questions you may face in that topic. The other type of question is here. Like we did in the previous section, we are given one trigonometric function in a region, in a quadrant. You are asked to find others. In order to find the sine and cosine theta over 2, you need to know cosine theta, right? In all of the formulas, you have cosine. Let me write the formula for both first. Formula for sine theta over 2 is 1 minus cosine theta over 2. Formula for cosine theta over 2 is equal to 1 plus cosine theta over 2. Depending on the sign of the theta over 2, the answer changes, the sign changes. So as you see, in both of the formulas, we need cosine theta. What I am given here is tangent. So you just form a right triangle in which quadrant? It's between 0 and 90. 0 and 90. So it's in the first quadrant. In the first quadrant, your theta is here. So tangent is, it's opposite over adjacent. Opposite is 4. Adjacent is 3. You either use your Pythagorean theorem to find the hypotenuse or just recognize the spatial triangle here, 3, 4, and 5. So what we need here is cosine. So cosine theta is adjacent over hypotenuse. Your adjacent is 3, hypotenuse is 5. So now I got my missing value. What about the sine? What can you say about the sine of theta over 2? Your theta is between, theta is between 90 and 0. So what about your theta over 2? So you divide them all by 2 to see where it is. 0 over 2 is 0, is less than theta over 2, is less than 45. So theta over 2 is between 0 and 45, so it's still in the first quadrant. In the first quadrant, the sign of sine and cosine are both positive. They're both positive. So just substitute the value that you found here first. So what you have here for cosine, you have 3 over 5. So let's substitute in the formula. 1 minus 3 over 5 over 2. So let's equalize denominators. 5 over 5 minus 3 over 5. 5 minus 3, 2 over 5 over 2. You can find the result as, when you do the operations, 2 over 5 over 2, which is 1 over square root of 5. You rationalize it, you are going to 5 square root of 5 over 5. Let's do the same for cosine. Let's just replace the unknown. 1 plus cosine theta, which is 3 over 5 over 2. So equalize denominators, multiply top and bottom by 5 here. So 5 over 5 plus 3 over 5, which is 8 over 5 over 2. So you are going to find the result as 2 over square root of 5. Rationalize it. 2 square root of 5 over 5 is the result.